In types of multi-range ammeter circuit connection, this diagram shows the Ayrton shunt connection. So I'll solve a question which requires us to find the resistor which can be put in this Ayrton shunt for the ranges 0 to 1 ampere, 0 to 5 amperes, and 0 to 10 amperes. The resistance of the meter coil is 50 ohms. The full scale deflection current is 1 milliampere. So I'll start this off by putting off for the range 0 to 1 ampere, which is up here. When it is that way, the current will flow from R1 to R2 and R3. This current will be the I total minus the full scale deflection current, which will be equal to the full scale deflection current times the resistance of the meter coil. So at this junction here, the voltage moving on to the first resistor, second, and third resistor will be equal to the voltage moving on to the meter coil. So for solving this, I have my IT is 1 ampere. My full scale deflection current is 1 milliampere. I will divide this by 1 minus 1 times 10 to the power negative 3. And by 1 minus 1 times 10 to the power negative 3. So this becomes 1. So I have, so dividing the whole of this here, I'll have 0.05. This is my equation 1. For range 2, which is 0 to 5 ampere, I'll have the switch will now be at this point. So when it's at that point, the full scale reflection current will be shared by the first resistor and the resistance of the meter coil, while the rest of the current will be shared by the second and third resistor. So the rest of the current, which is IT minus the full scale deflection current, will be shared by the second and third resistors, while the full scale deflection current will be shared by the first resistor and the resistance of the meter coil. So substituting the values that I have that my R2 plus R3, 5 minus 1 milliampere is equals to the 1 times 10 to the power negative 3, R1 plus 50. So what I'm going to do is to divide by 5 minus 1 times 10 to the power negative 3, and I'll then divide here by 5 minus 1 times 10 to the power negative 3. So these two cancel. I have R2 plus R3 is equals to R1 plus R50 times. So 1 times 10 to the power negative 3 divided by 5 minus 1 times 10 to the power negative 3. I have it as 2 times 10 to the power negative 4. I will make this simpler by removing the brackets such that I have 2 times 10 to the power negative 4 R1 plus. This is my equation 2. So without even moving on further, I can substitute my R2 plus R3 into the first equation. So I'll substitute equation 2 into equation 1 such that I have R1 plus 2 times 10 to the power negative 4 R1 plus 0.01 is equals to 0.05. Now this term is R2 plus R3. Putting 0.01 to the other side, I have 0.05 minus 0.01, so I'm left with 0.04. At this point, I have 1 plus 2 times 10 to the power negative 4 is just the same as 1.002 R1. So I'll divide by 1.002 on both sides, and I'm left with my R1 as 0.03999 ohm. So I have my first shunt resistor. The next thing I'll do is I'll substitute my value of R1 into the second equation, such that I have R2 plus R3 is equals to 2 times 10 to the power negative 4 times 0.03999. So I'll then have my R2 plus R3 as 0.01. This is my new equation 2. So for the range 0 to 10 ampere. So the switch will now be here at this point. So the full scale deflection current will now be shared by R1, R2, and the resistance of the meter coil. R3 will share the rest of the current, which is IT minus IFST. So putting my equation in order, this will be IT minus IFST multiplied by R3 is equals to the first resistor plus the second plus the resistance of the meter coil multiplied by the full scale deflection current. So now the total current here is 10, the full scale is 1 milliampere. My R2 is still unknown, so I will divide both sides by 10 minus 1 times 10 to the power negative 3, such that I have 1 times 10 to the power negative 4. So I have R3 is equals to 0. Times 1 times 10 to the power negative 4. Removing the brackets, I have my term as 5.0399 times 10 to the power negative 3 plus 1 times 10 to the power negative 4 R2. So I'll just ignore past the decimal point. So I'll have my third equation as 5 times 10 to the power negative 3 plus 1 times 10 to the power negative 4 R2. So I had my equation 2 as R2 plus R3 is equals to 0.0. So I'll substitute equation 3 into the equation 2. So I'll have R2 plus the contents of R3, which is 5 times 10 to the power negative 3 plus 1 times 10 to the power negative 4 R2 is equals to 0.01. So 1 plus 1 times 10 to the power negative 2 R2 is 1.000. So I ignore the zeros and just write R2 is equals to. So I have my R2 is equals to 5 times 10 power negative 3 ohm. Since I have my R2, I then substitute my R2 in equation 3, and I have my R3 also is 5 times 10 power negative 3 ohms. I had my R1 as 0.0399 ohms. So this is how you solve for finding the shunt resistors in the Ayrton shunt. Subscribe to my channel for more videos. The same.